indicates warmer than normal temperatures. So you can really see the pattern that's evolved in the last couple of weeks across both the high plains and the Midwest. Generally, March temperature trends follow the pattern of rankings observed within February. For the last couple of weeks, Montana, northern Wyoming, and western portions of the Dakotas have been extreme cold to really cold, extremely cold. Here, the temperatures range from between 2 to 15 degrees below normal, as depicted by the green to purple shading extending up into eastern Montana. And really, these conditions have contributed to a persistent snowpack and little change in stream flow for the upper Missouri River Basin. As we move to the right, the band of temperatures from 2 to 5 degrees above average extends from Colorado, Kansas, Nebraska, and then it extends upwards to Iowa and states surrounding the Great Lakes region. Warmer temperatures in the Great Lakes region especially have contributed to a significant loss over the last month of ice cover, and especially in the last couple of weeks. Okay, so here's a look at March's precipitation as a percentage of that mean value from 1981 to 2010. I'll just walk you through this plot, an example of how to read this. Gray areas within this plot will represent a 0% of the mean, or essentially no precipitation during the time period. So gray is bad, especially when we start looking at Colorado and Kansas. Light green areas here would represent approximately 100% of the normal precipitation for the time period. And if we move further up in magnitude, blue to purple shading indicates upwards of 200 to 500%. You could think about this as almost 5 times the normal precipitation within the last couple of weeks. So really the story here is, again, in the Midwestern region, we saw a return to kind of below normal, as indicated by the light green to orange shading extending around the Great Lakes area, and that this is probably well received given the extensive precipitation that occurred in late February. Moving westward, a large portion of North Dakota, northeastern South Dakota, and eastern portions of Wisconsin and Iowa saw 2-week precipitation amounts of greater than 200 to 400% of normal. In the southwestern portion of the region, abnormally low precipitation, again moving to parts of Wyoming, Colorado, Kansas especially. They saw abnormally low precipitation amounts with the majority of Kansas, Colorado, and Wyoming receiving 0 to 10% of the normal amount in the last 2 weeks. So it's staying dry. Okay, so just to move beyond kind of a measure of total precipitation, let's take a look at snow conditions across the region. Again, the National Operational Hydrologic Remote Sensing Center's modeled snow water equivalent is shown here in this slide. That's a mouthful. Snow water equivalent represents to think about snow water equivalent, it represents the depth of water that we would have if we completely melted the snowpack in a given location. So I'll move from west to east in my description of this figure. Across the mountainous region east of the Continental Divide in Montana, Wyoming, and Colorado, we've accumulated between 2 to 6 inches of snow water equivalent across the valley bottoms and to some degree within the plains. As we move up to higher elevations, upwards of 20 inches of snow water equivalent has been recorded at higher elevations, especially as we progress into Montana and the mountains of Montana. Moving east from these states to the plains, there's a fairly distinct boundary in SWE or snow water equivalent that begins at Montana's southern border and extends east towards southern Wisconsin. Below this line, very little snow water or trace amounts of snow water equivalent exists, and that's indicated by the kind of boundary of the gray shading there. Above the border, or above that border, so moving into South Dakota, excuse me, above the border, about 1 to 4 inches of snow water equivalent is accumulated. Again, this extends from eastern Montana, western North Dakota, northern Minnesota, and upper portions of Wisconsin. So Let's talk a little bit about where we stand in terms of our kind of average snowpack conditions, especially in the mountainous region in the upper Missouri and Platte River basins. I've shown the percent of average snow water equivalent for March 14th in the mountainous region of the High Plains. Again, these data are measured from snow water equivalents at snow pillow sites located across the Eastern Continental Divide. Portions of Montana east of the Continental Divide, indicated by dark blue here, are between 130 to 161% of the 30-year median. This suggests that snowpack contributions to Missouri could be slightly larger than usual. Really, it's hard to tell yet. It's going to be important to pay close attention to the timing and rapidity of snowmelt as temperatures begin to rise this spring. When and how rapidly that happens is going to be important. In Wyoming, northwestern portion of the state are 100 to 126% of normal, but this transitions to slightly below normal to normal as we move further east within Wyoming. Moving into southern Wyoming and Colorado, snow water equivalent really decreases. In southern Wyoming and northern Colorado, basins are between 72 to 81% of normal. Southern Colorado is in a large deficit right now with snow water equivalent from 51 to 58% of normal, so pretty low for this time of the year. It's unlikely that it will recover. Okay. So again, I mentioned mountain snowpack is the primary factor used to predict May through July runoff, especially in the upper Missouri River Basin. During the 3-month runoff period, roughly 50% of the annual runoff enters the main stem system of the Missouri and as well the Platte as a result of mountain snowmelt and in addition, rainfall runoff. The figures that I've shown here in this slide include time series plots of the average mountain snow water equivalent beginning on October 1st of 2007 and through the period to yesterday, so the current water year. The current average snow water equivalent values are based upon all NRCS snowtail gauges for the headwater basin above Fort Peck, so on the figure to the left, and the incremental basin from Fort Peck to Garrison. So the current average snow water equivalent values are indicated by the blue shaded area, and the red line here indicates the 1981 to 2010 average, again indicated by the red line. So on March 12th, the mountain snow water equivalent in the gauge or the area above, the total area above Fort Peck reached was about 17.9 inches of snow water equivalent. This represents about 128% of the average. So we're doing well there in terms of an above average snowpack and snow water equivalent. The mountain suite in the total Fort Peck to Garrison reach was about 16 inches. This is again high. It's about 132% of the average for this time of the year. So taking a look at the Platte River Basin, here's a similar figure for the North and South Platte River Basins coming out of Wyoming. As of March 13th, the mountain snowpack snow water equivalent in the total North Platte reach was about 13.8 inches, and here it's about 81% of the average. So getting close to average conditions or 100% of the normal. Still need a bit of snowfall to reach that average condition. Mountain snowpack in the South Platte is currently at about 8.9 inches of snow water equivalent, or about 76% of the average. Each of these basins generally reflect the slightly below normal snowpack observed in the eastern portions of Wyoming. Okay.
Colorado, that is.
Excuse me. Thank you. Lots of states to keep track of. Thank you, Doug. All right. Let's take a look at the kind of current soil moisture anomaly, and generally this pattern here reflects the recent precipitation as well as the persistent drought conditions in some areas of the region that have occurred since last fall. Soil moisture is factored into forecasts as an indicator of wet or dry basin conditions, so it's a really important variable to consider in terms of the potential for drought or flooding as we move into the spring. In this figure, I've shown the Climate Prediction Center's modeled soil moisture anomaly for March 14th deficits. So I've shown here both deficits and surpluses of soil moisture, with red shading, orange to red shading indicating deficits, and light green to dark green shading indicating surpluses of soil moisture. Generally, when you look at this, areas that really stand out in terms of soil moisture deficits include Kansas at the extreme, large chunk of very red area there, deficits upwards of about 80 millimeters. The Missouri as well, the western portion of Colorado, North Dakota, and a portion of northwest South Dakota. Locations with really high soil moisture surpluses, and again, due to the high precipitation in the last month, include states surrounding the Great Lakes region, Kentucky, and generally a sliver of moisture that extends through portions of Minnesota, South Dakota, and into Nebraska. Okay, so let's zoom out and kind of talk about the implications of the soil moisture, precipitation, as well as persistent snowpack in the High Plains region for streamflow. Looking directly at current streamflow conditions, here's a large map of USGS stream gauges and flow rankings across the Plains and Midwest region for the past week. So these are average flow conditions for the week of March 14th. And across the gauge network, blue symbols indicate greater than 90 percentile flows, so fairly high flow periods for the time. Light blues between 76 to 90th percentile. Green is 25th to 75th percentile, and orange is much lower at the 10 to 24th percentile. So very low flow conditions associated with drought and low flow. One thing to note is that when you look across Montana and the Dakotas here, there are a lot of gauges that aren't currently appearing on the map, especially in eastern Montana and Dakotas. This is due to frozen stilling wells and the extreme cold that's occurring within these reaches. So rivers are generally frozen at these locations, and therefore stream flows are not being recorded. The big story this past month was the extensive amount of flooding that occurred across Ohio, Indiana, Illinois, Michigan, and Kentucky. And that was, again, a result of late February's record rainfall amounts. I'll talk a little bit more about these areas in the next slide. We'll kind of zoom in on that Great Lakes region. Generally, March runoff for the upper Missouri River Basin and the Platte River Basins are averaged below what we would expect for this time of year. However, this is probably going to change as our large snowpack melts out in the spring. Again, the majority of that region and snowpack within those regions is still very cold and frozen. Below normal temperatures in the upper basin really haven't allowed much melting of the plains snowpack, and we expect to see runoff increase really in the later part of March and moving into April. I'd also point out there are numerous gauges in western Colorado and portions of Kansas and Missouri that are below average to much below average. And this was related to the lack of precipitation. Again, those persistent drought conditions from last summer into fall. So here's a closer look of really at the aftermath of the floods that I mentioned in the Midwest region. I wanted to take a minute to really highlight these. It was a fairly significant or very significant flooding event. The figure on the left here shows gauges along tributaries to the Ohio River that are currently still at flood stage, and this event occurred again in late February. The figure on the right shows the stage of the Kankakee River in Shelby, Indiana. And what I'd like to point out is there's good news here. The floods have occurred and the floodwaters are beginning to recede. And again, that's related to a period within the last 2 weeks of abnormally low precipitation. It's going to be really important as we look towards the 1 week and monthly forecast to consider precipitation that might occur in the next couple of weeks. It looks like it's going to get slightly wet again. We'll talk about that later. But flows as of right now are beginning to recede. But definitely some record high flows, close to record high flows that occurred in this region. Okay, moving on to soil temperature, we'll take a quick look at these. Generally, it's what you would expect to see given the description of temperatures and and as well as snowpack across the High Plains region. Temperatures, again, are important for plant germination and growth, and also for understanding where rainfall or snowmelt may or may not infiltrate into soils due to frozen ground conditions. On this slide, I've showed recent observations of 4-inch soil temperatures from the regional mesonet, and I've also included, because it's near and dear to my heart, an inset showing 18 newly added sensor locations for the Montana mesonet. As you might have guessed, surficial soil temperatures in Montana and the Dakotas, so generally cooler temperatures are indicated by blue to purple shading, and warmer temperatures progressively get lighter in color, so lighter blue towards green. So as we look at Montana and the Dakotas, the surface soil temperatures are fairly low, and they range from 30 to 25 degrees Fahrenheit. In the Midwest, the soil temperatures are warmer, and they range from 40 to 50 degrees Fahrenheit, depending upon proximity to the Great Lakes region. Okay, so moving on to the Great Lakes specifically, here's an image showing the water temperatures and ice cover extents for the Great Lakes. And the big news here is there's been a lot of change since last month. Water temperatures here in this figure from higher to lower indicated by light blue to darker blue shading. Currently, there is a high around 40 degrees in deeper waters, transitioning to lows in shallower regions surrounding the banks, down to about 31 degrees. So this is generally a bit warmer relative to the temperatures observed last month. And as a result of increased air temperatures, ice covers decreased pretty dramatically by almost 30% for the Great Lakes region as a whole, if you average across all of the lakes. And again, it's due to the abnormally warm air temperatures in the last couple of weeks. Lake Superior has about 50% ice cover. Lake Michigan is about 12% ice cover. Lake Huron is at about 22% ice cover. Lake Erie is at around 14%. And Lake Ontario is the lowest at around 3%. Okay, so let's take a look at the latest U.S. drought monitor. This is hot off the press from this morning, courtesy of Richard Tinker. Really, there's been some interesting trends in drought. Again, really with a focus on Colorado and Kansas. It's really dry. Drought persisted or worsened from Kansas westward into Colorado. We saw a change. Extreme D3 drought now covers a large swath across south central and southwestern Kansas, and as well southeastern Colorado. The last 5 months have been really dry from southern Kansas and adjacent Colorado, and most of this area has recorded only about a fifth to a few tenths of an inch of precipitation since early October of last year. And really, the impacts have steadily intensified. As we move farther north, dryness and drought eased somewhat in northeastern Montana, and it remained mostly unchanged farther east in the Dakotas, though there was some D2 expansion introduced in southwestern North Dakota. Related to the drought conditions in the Dakotas, winter wheat crop here has been affected by the dryness, but really not to the degree observed in the southern plains, again in Colorado and Kansas. South Dakota reports about 32% of its crop in poor or very poor condition, and 18% is in poor to very poor in North Dakota winter wheat crop. Going back to the Midwest, again, with that extensive precipitation, no changes were introduced in the Midwest region, and it really continues to benefit from the heavy precipitation a couple of weeks ago. Okay, so talked a lot about the kind of conditions that we've seen in the last 3 months, as well as the month and the last couple of weeks, and I want to take a minute to highlight some of the impacts that have been observed across the region. I've kind of broken this up into cold and snow, agriculture, and stream flow and flooding. Those seem to be the biggest impacts that we've observed, as well as development of fires, especially in Kansas. So I'll kind of highlight those three different categories of impacts. One of the ones that I've been following closely and that has just persisted for a long period of time, we've had many blizzards that have hit in northwestern Montana, and it's really affected the Blackfeet Nation. So a series of blizzards, February 23rd to 27th, another one on March 6th, and there's one occurring as we speak right now. So it's just been inundated. With these blizzards comes extreme winds, heavy snow, and extreme cold temperatures. So in some locations, there's 10 to 15 plus feet of snow drifts. This has created literally impassable road conditions. People have been stranded in their homes, and people have been trapped and looking for assistance. There have been obviously many and numerous road closures. Dennis Longknife reported that people haven't been able to work. Everything's shut down. And another blizzard hit right after that and dropped at least 2 more feet of snow, shutting down again all travel. So emergency crews are working hard to clear the area. And as of right now, there's a statewide emergency a state of emergency for this northwestern region in Montana, especially on the Blackfeet, Fort Belknap, and Northern Cheyenne reservations, and as well in Glacier and Golden Valley counties. Moving much further Midwest, and this was yesterday, I actually saw this all over the news, a snow kind of whiteout conditions March 14th in central Ohio caused a 81 vehicle pileup. Luckily, nobody was injured, but that has to be some kind of record for in terms of number of vehicles involved in a traffic accident. Okay, moving on to agricultural impacts. You know, with the theme of very cold conditions and lots of snowfall, especially in Montana and in northwestern Montana, I've shown a picture here to the left from MSU Extension and then off of the Blackfeet Reservation. You know, it's difficult for producers to get to their cattle as well as to get out and provide feed for them. If you're providing range forage, the range is covered in snowpack. So there's cattle loss due to extreme cold during calving times and generally a lack of feed. You know, there's just a general worry in eastern Montana. And Laura Edwards highlighted this as well in the Dakotas about drought impacts as we move east, persistent drought impacts, especially in the Dakotas and their effects on rangelands going into the spring. In Kansas, this is, I believe this occurred yesterday afternoon. There's an emergency drought status now declared across the entirety of the state. So restrictions for travel have been lifted in terms of hay and feed hauling. There's water hauling occurring from federal and state reservoirs. At this time, winter wheat is about 10 days behind in its development. And really the story is that crops planted after October really haven't had time to develop deeper roots because of the precipitation deficit. There was some deeper moisture prior to October associated with some late summer rainfall, but crops that weren't planted early haven't developed those deeper roots. So 28% of wheat in Kansas is in poor to very poor condition, and about 44% was reported as fair. One interesting note in Ohio, with some slightly warmer temperatures in the last couple of weeks, red maples and silver maples actually went into their first bloom due to those warmer temps.
And we have an update on the Kansas wheat crop, thanks to Brad Rippey from the USDA, who's quick to note. Thank you, Brad. Winter wheat in Kansas, 53% very poor to poor. I think those are, yeah, not so good. But thank you.
Thank you. Okay, moving on to the Midwest and the event that's probably caught everybody's attention. Major flooding in the Midwest. Again, that record precipitation in February led to extensive flooding. From what I could gather, there have been at least 3 deaths and obviously extensive damage to homes, buildings, vehicles across Indiana, Illinois, Ohio, Michigan, and Kentucky. Dennis Toddy reported extensive road closures. He was in a couple of those and waiting for a bit to make it where he's trying to go. Just some notes in terms of flood stages for some of the larger rivers. The Ohio River flooding at Cincinnati crested at 16.5 feet, and this is the highest recorded since the large 1997 flood. The second highest historical crest was measured on the Grand River in Michigan, and Ohio River at Uniontown Dam in Kentucky recorded its highest ever stage. I believe its period of record is only about 10 years, but it definitely recorded its highest record stage. So pretty significant flooding that occurred across the Midwest. And Doug, you might be able to comment to that better than I can.
I won't dwell on it, except that it was unusually, I don't know if the timing of the seasonality of the flooding wasn't all that unusual. It certainly wasn't that unusual in terms of a La Nina situation. We expect that area to receive more than normal precipitation. That area being the lower Great Lakes and Ohio River Basin. Generally, the Kankakee set an all-time record at several points, which is northern Illinois, northeastern Indiana, and there were some records as well in southwestern Michigan.
Great, thank you. Okay. So kind of the last impact, and this is something we'll have to keep an eye on as we move into the spring and especially in the summer. Fire is always an issue for portions of the United States. Montana had one of its record fire years last year in terms of number of acres burned, and there's still worry about that as we move into the spring and the summer in eastern Montana in terms of just persistent soil moisture deficits in the upper northeastern portions of Montana and as well into the Dakotas. So I've shown a map here of the wildland fire potential through the period of April 2018, so the 1 month fire potential outlook. And then the other big story is again in eastern Colorado, and then pretty much the entirety of Kansas, which actually has a lot of current fires as we speak. There's a significant potential for wildland fire in these regions, and that goes back to the Kansas governor's declaration of drought emergency, as well as fire warnings and watches across all 105 Kansas counties. I did a search yesterday, and there are 12 small fires burning across the state, but 2 kind of major, larger wildfires that have been reported: the Baller and I-70 milepost 310. Doug, you sound like...
I'll just add, the only thing I'll add to this is that if you look, this is for the month of April.
Yeah.
In terms of what the potential, but I don't know if you have the rest, but May and June at least, and I'm guessing the rest of the summer will also show similar red areas, at least in the southern plains. For this call, really southeastern Colorado and Kansas. Yeah, and I didn't include that here, but just from memory, Colorado and in Kansas that expands, and interestingly, the portion of above normal potential in eastern Montana and North Dakota disappears. So we'll see how that goes. But this is taking into account current conditions and antecedent weather, as well as projected weather moving forward. Fuel types, both live and dead fuel moisture. So there's a lot that goes into this. And they're issued every month on the first of the month, apparently.
Okay, so that's kind of a list of impacts and things to look out for. And I'm going to kind of switch gears now. Let's move on from current conditions to the outlook for the upcoming week. And it looks like it's going to get wet again, and hopefully some of that extends down into eastern Colorado and Kansas, though it probably won't be as significant as the higher plains area and Midwest regions. I've shown here the 7-day quantitative precipitation forecast for the United States. Shading here represents the depth of expected precipitation in inches. So the expected values and generally across the high plains and Midwest region range from 1/10 of an inch in green to upwards of about 1.5 inches in purple. So generally, storm systems forecast to come offshore. It's actually happening today in western continental U.S. And this is going to increase the likelihood of above normal precipitation for Montana, southeast Wyoming, and South Dakota. The storm's expected to travel this evening across the northern high plains region and extend towards the Midwest by Friday. Tonight as well, the storm's expected to expand southeast through Nebraska and into eastern Kansas, and the hope is it's going to hang out in Kansas long enough to alleviate some of the drought conditions. By Friday morning, the storm's expected to progress to the Midwest states with precipitations based on this map of up to 1/2 inch. So it's going to be important to keep an eye on how much precipitation is actually realized and how intense it is for much of the Midwest, because it's still, it's still fairly wet, as indicated by that soil moisture map earlier from that late February precipitation. Okay. Moving a bit further forward, so here's a look at the Climate Prediction Center's, NOAA's Climate Prediction Center's 8 to 14 day outlook. And some of this reflects the storm track I just discussed, as well as what's going to occur or likely to occur in the upcoming week. Temperatures are expected. I've shown temperatures here on the left-hand side. Temperatures are expected to be below normal for the entirety of the region, and this is indicated by dark blue to light blue shading in the figure on the left. So again, just generally, we're expected to be below normal, and this is a continued theme, especially in the High Plains region. In the figure to the right, green shading for really the entirety of the region, excepting a small portion of Colorado and Kansas. The green shading indicates the majority of the region is expected to be above normal for precipitation. Again, portions of southeastern Colorado and western Kansas are tilted towards normal to below normal precipitation over the next 14 days. Okay, so looking past that 8 to 14 day outlook, it's important to consider the El Nino Southern Oscillation, and really this is just changes in the Pacific Ocean sea surface temperatures, and these impact regional air circulation patterns and in turn our temperatures and precipitation. As we all know, we're still in a weak La Nina condition, and we experience that all winter. Typically during La Nina winters, we can experience cooler and wetter conditions in the upper portions of the high plains in the Midwest, and that tended to be what happened this year or this winter. Typically, though, the La Nina dissipates into the spring and summer, and we move back towards ENSO neutral conditions. So as a general theme or rule, this results in less predictability in terms of the longer term outlooks or forecasts released by the CPC. So here on the figure to the right, I've shown early March El Nino Southern Oscillation forecast. It's a probabilistic forecast. And again, it's on the figure to the right. And the general theme here is overall the ocean and atmosphere system and modeling suggests that La Nina is indeed weakening, and a transition from La Nina to ENSO neutral conditions is most likely during the March to May season. So 55% chance that transition will happen somewhere between March and May. Afterwards, neutral conditions are likely to continue into the second half of the year, so through the summer, extending potentially into the fall.
And just to help better understand what the ENSO forecast really means for us in this region and across the U.S. as a whole generally, is that once we sort of get into April, May, certainly June, and in the summer months, the connection to anything that's going on in the Pacific, I should say, in the equatorial area, is much less than it is during the cooler season. So these become less important, if you will, through the summer to some degree. Occasionally they can help us with some predictability, but generally the implications are simply just less during the warm season.
Thanks, Doug. Okay, so with those caveats and thinking about the 1 month outlook, here I've shown the 1 month April outlook, and it generally reflects still La Nina conditions, but weakening La Nina conditions. On the figure to the left, I've shown temperature, the kind of likelihood of below normal temperatures or above average temperatures. The theme persists in Montana. It's expected to be cooler than normal. There's a bullseye of cold temperatures over or cooler than normal temperatures over Montana. To the south, portions of Wyoming, Colorado, Kansas, Missouri, and Kentucky are expected to be warmer than normal. Equal chances of both above normal, or below normal temperatures occur for the remainder of the region. So there's less predictability there. Moving to the figure on the right for precipitation, it's expected to be tilted towards above normal, extending from Montana, North Dakota, and across states in the Midwest region. And again, going back to drier conditions in Colorado and Kansas that are likely, continued dryness is probable for Colorado and western to central Kansas. So below normal precipitation expected in those two states. Okay, so let's go out a little bit further to the 3 month outlook. So April, May, and June. The southern portions here, so again, temperature is on the left-hand panel. Southern portions of the Plains region and southern Midwest states are predicted to have above normal temperatures. So you can see that with the band of orange to darker orange shading that extends across those states. Equal chances of above normal, or below normal temperature occur for Montana, North Dakota, Minnesota, and Wisconsin. Moving to precipitation, and the figure on the right, precipitation is expected to be above normal for Montana, North Dakota, and all of the states within the Midwest region, excepting Missouri. As with the 1 month forecast, Colorado and Kansas are again expected to be below normal in terms of precipitation. So looks like those dry conditions, or there's a likelihood that those dry conditions will continue to persist across those two states. So just wanted to take a minute and thank everybody for their time and for tuning in. And I'll summarize kind of the general theme of this webinar. It's been particularly cold winter in the upper high plains region, and normal to slightly above normal for the Midwest in terms of temperatures. Record to near record rainfall occurred in February for Michigan, Ohio, Indiana, and Illinois, as well as Kentucky and Missouri contributed to extensive flooding across the Midwest. Snowpack is above normal in the Missouri Basin, and it's approaching normal in the Platte River Basin. It remains below average farther south across much of Colorado. In terms of drought, it's expanding in the Southern Plains region from Colorado, Kansas, and into Missouri. And based on the outlook and monthly forecast, it looks like that may continue. Drought persists in northeastern Montana as well as the Dakotas, although there were some slight improvements this week. And then finally, a transition to ENSO neutral conditions is likely during the March to May season, and we will keep an eye on that. Oh. And I'll wrap it up there. I thought I had another slide with email contacts and other additional information sources. I will update that and give it to you, Doug, so it can be posted on the PDF and online version of this presentation.
That's fine. Thank you, Kelsey. Very good talk. We have several questions and such, and just to save you from using all your words today, I'll try to cover as many as I can, as quickly as I can, Kelsey, but feel free definitely to jump in on any of these that you might know a little bit more than me, which is pretty easy. So I'll start at the top. Concerns about areas with low precipitation % of mean for the growing season. Well, Benjamin, that comes from Benjamin Diamond, and the answer to that is absolutely. And most of those areas that Kelsey already pointed out are in the high plains, southern high plains to central high plains, There are some fields that have been more or less abandoned and that will not grow a wheat crop on, and or the wheat grew and then it more or less died or got grazed out or something like that. So there are those are the concerns there. Further north into the Dakotas, there is concern, maybe not quite the concern that we had 2 or 3 months ago due to some snow up there, but there is still some concern for grazing lands coming back from the severe or extreme, actually, drought that they had last year. So they need to make up, if you will, some precipitation. And frozen ground up there, since it has been relatively cold, doesn't really allow a lot of moisture to get into the soil at this point.
Yeah.
So spring rains are going to be really important. Go ahead.
I was just going to add one thing I didn't mention, but I did look at this information. If you look at the frost depth in Dakotas and especially into Montana, in some cases that frost depth extends from almost down to 40 to 50 inches. So soils in a lot of locations, especially in the plains areas, are very cold, and that frost depth extends very deeply. So that can have implications for runoff.
And I think, Benjamin, you wanted to go back to a particular slide. I'm going to put you on you're active right now, Benjamin. You can talk. You want to go back to a flood stage slide? I don't remember which slide that would be, Kelsey, but can you go back way up there? It was one of your flood point data things. Maybe that one. Benjamin, is that the one you were referring to? If you're still, yeah, you're still on.
Thank you.
Did you have a particular question about those?
No. I just wanted to, I didn't get a good enough look at it.
Okay. Yeah, that's, those are tributaries to the Ohio for the most part. Sort of the western Indiana, eastern Illinois areas. And luckily, they haven't received heavy rains in the last week or two, so they're on the downslide in terms of major flooding and such there. Another question, a really good question about, is there a national data set of MesoNet data, one source for all regional MesoNet data? And there are a bunch of regional versions. I'm not necessarily aware of those that are national MesoNet ones. Obviously, we can show you, we can sort of show information which he did across areas when it comes to temperature and precipitation, but some of the other variables like soil moisture, like that one, yeah. Soil moisture and soil temperature are really hit and miss depending upon the individual state. There is not while there are some national sort of federal networks, they're very sparse for the most part when it comes to soil and things like that. So we're kind of stuck with, patching things together, and sometimes we don't even do that, do a very good job of that. So that's something we need to look at and work on, to be honest, and have been for some time.
Yeah, I would say the National MesoNet program is very aware of that and working towards that. And, I think soil moisture is the big question for a lot of people. And I think new MesoNets are working to add that soil moisture information as well as incorporate information from existing MesoNets.
Yep. And then we had another question about more or less wildfires as they do wet seasons followed by hot and dry summers, that kind of thing, lead to more fires, which are unmanageable and all that business. And I would say, for the most part, they do. There are seasons, like anywhere, there are seasons for fires. And in the high plains, for example, there's not a lot of trees there, but there is a fire season, at least one fire season. And the spring fire season is if you will, green up. In other words, nothing is really growing. Everything's brown, like you can see in that picture there. And fires really go fast. And there's a lot of wind during the spring. So they're driven by 20 to 50 mile an hour winds on occasion. This year, there is probably a little more concern. There was a relatively wet last year, and maybe even the year before that, so there were a lot of more fuels, grasses, whatever, to burn in these regions. You actually, the remark was for the Ozarks, and I don't have a lot of familiarity with the Ozarks and any sort of understanding of fire potential down there, but it would make sense similarly there. The one thing I'll say about once you get to the Ozarks and places sort of east and north of there, even south of there, is that it's a pretty humid climate, and it really takes a pretty severe drought. It's not like California where it absolutely will dry out every summer. Not necessarily the case in some of those eastern U.S. climates. So it's a different animal, but I'm sure that there are cases where you could say, like in 2012, when our dew points were extremely low, in other words, very dry, and the conditions were very dry, the fire danger was well enhanced over what it would normally be for that time of year. Okay, we got Brad Rippey's corrections, and then we have an ENSO. Oh, why does ENSO become less important during the summer? It's sort of a straightforward answer, but the maybe the understanding is a little bit difficult. So during the cooler times of the year, that jet stream that you see sort of demarked there on the map, that blue line, really can dip way south into not all the way to the equator by any means, but certainly into the subtropical areas, and get influenced by warm or cool waters, depending upon what's going on along the equator, and really pick up, if you will, energy, storms, humidity, whatever you want to call it, and pull it into the U.S. during the cool season a lot more readily than it can during the summer season. Because that jet stream, if you will, lifts further north and tends not to interact very much in the subtropical realm of things. So all systems sort of move to the north, and as does the sort of pipeline for that energy out of the Pacific. That's why ENSO impacts tend to be less. That's a very simplistic way of answering your question. But the summertime just doesn't have the connection, a strong connection to the Pacific as it does in the winter. And Kelsey, yeah, you want to say something?
Well, I was just going to mention too that it starts to get more complex, and so it's an easier one to discuss in terms of its impacts on our weather patterns. But we also have to consider a lot of other kind of regional connections, like the Arctic Oscillation, the Madden-Julian Oscillation, and others. And so they all interact, and they're used in these models for prediction of our temperature and precipitation trends. So it gets complex.
Yep. And Kelsey, will you go to your extra slide that I know you have hidden down there at the very, very, very bottom on the Missouri Basin?
Absolutely.
For the Missouri Basin. There's a question about, there you go. Whoop.
You said Missouri?
I did.
Yeah.
And really the question was the assessment. What is our general assessment of the flooding potential for farmland, the Missouri River Valley, or the heavy snowpack in the upper Missouri cause flooding problems? So there is, I would say, because it has been so cold and the snowpack was able to develop not only in the mountains but on the plains in Montana, there's concern, I would say, locally on tributaries. There was probably more concern on the tributaries to the Missouri than there is the Missouri itself at this time. My understanding of how the Corps runs their reservoirs, which is not complete, by the way, so you can quote me if you want, but but it may not be accurate. My understanding is that the flood pool is complete. They have the whole gamut to work with. So where we have frozen soils and frozen rivers and things like that with really deep ice and still a lot of melt to go, there is probably a little bit of enhanced concern for those. What we really don't want to happen is for, let's say, Montana to stay cold for another month. I know Kelsey probably doesn't either, but for another month or two below normal and not melt some of that snow off. What we really need is sort of gradual melt as opposed to flash melt, if you will. Not that that alone is going to cause major flooding or anything, but any precipitation on top of that could cause problems, especially for the tributaries. In terms of the lower Missouri, there are some enhanced points here of higher risk. Those are common in, again, mostly tributaries to the Missouri. Any spring, we have a lot of rain this time of year, actually starting in April and May and June for that matter, and we can get flooding just about any time during that because of normal variability, I guess you would say. And then let's see, one last question here. There are updated 1-3 month Climate Prediction Center outlooks that weren't shown as of March 15th versus. Hold on a second, Steve. I'm not quite sure I'm going to have you ask me that if you're still on. Yeah, there you are. Steve, can you ask me that? Go back to the April, May, June outlook, would you? Yeah. Well, that's the May, June. April, May, June. Yeah, Steve, did you want to say this is the latest one? Oh, you know what, Kelsey? You grabbed the wrong ones. So, thank you for pointing that out. Did you see that, Kelsey?
I'm looking at it right now. Yeah.
You've got the March 15th ones in there. So what I'm going to do is grab back the show my screen here. Hopefully you can see a map. Everybody see my map? Or not?
I do.
Okay. This is the April, May, June current updated version of what Kelsey was going to show you for temperature and the probabilities of a lot of warmth across the U.S. and cold across Montana. Sorry, Kelsey. And the probabilities are pretty enhanced for the southern plains, actually. And if we want to look at precipitation very quickly, you see the below normal sort of sneaking into the southern parts of this region and the above normal precipitation. Not that much different than what Kelsey actually showed, to be honest with you. So those are the current 3-month maps for April, May, and June. If you just want to look at April, I think you might have had that one. But anyway, there's the April temperature map, and there's the precipitation map. So I'll go back. Temperature below normal, again, same areas for the most part. And above normal for the Midwest, some of the Midwest and some of the southern areas, and then for precipitation, enhanced over the Ohio Basin and enhanced over the northern plains as well. Sorry about that.
Yeah, my apologies, everyone.
Okay. Thanks, Steve. I'll mute you again. Good catch there. Appreciate that. I also had one more slide I was going to show if I still have it up. Yeah, this is the change in drought over the last 2 months, drought conditions across the region. What this basically shows you is how or if drought conditions changed on the drought monitor map. Where you see yellows, in fact, enhanced yellows, that's a 2-category change toward worsening drought levels. Where you see greens, light green to sort of dark green, you see improvement, if you will, in drought conditions in those regions. Just wanted to point that out in terms of showing you where drought is developing and where drought has sort of gotten better, if you will, over the last 2 months. Yeah. Any other questions or comments from anyone? All right. I will say I did start this thing about 5 minutes late, so the first 5 minutes are going to be cut off. Sorry about that, Kelsey. But we got the lion's share, so we'll record that. We'll have this recording online soon enough, and if you want the PDF and all that kind of business, I think in the invitation that I send out on a monthly basis, you'll see that there are links to those on there. So any questions, of course, by anybody, you can always reach me at doug.cluck, K-L-U-C-K, at NOAA, NOAA.gov. Thank you, everyone, and hopefully we'll see you next month for our April version of all of this. And thanks again to Kelsey for his help today.
Thank you, everyone.